Good evening. We're going to do 6.4, the triangle mid-segment notes. So you'll need those notes, a pencil, and a highlighter. You're going to go ahead and fill in the chart on the top of your notes, the points of concurrency. Please remember what the word concurrent means. Concurrent. It means 3 or more lines all intersecting at one point, and that point is called the point of concurrency. So that's all we've been doing in sections 6.2 and 3. So if you don't remember, go ahead and look back at those notes. We did fill them out yesterday as well. If at any point in time this is too fast for you, always feel free to pause. All right, so let's go. 6.4, the triangle mid-segment theorem. You use the triangle mid-segment theorem to find distances. All right, so basically if you know how to half something and you know how to double something, then you will do completely fine in this section. Let's go ahead and take a look at what a mid-segment is. You'll fill in the blank. A mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangle. And I'll show you what that looks like. On this triangle, it is on your paper. I've already marked each midpoint, but you do want to mark that the sides beside the midpoints are congruent. So this piece and this piece are the same measure. So you want to have those tick marks there. And then the same thing with the bottom midpoint. We'll call that point B. You want to also write that it is congruent. All right, and then the same with, we'll call it C. So a mid-segment connects two of the midpoints together. Like that, like that, like that. All right, so each of these pieces is called a mid-segment, and each mid-segment has a relationship with the side it is parallel to. So AB will have a relationship with this side over here. CB will have a relationship with this side. And then AC, a relationship with the bottom. All right, and that relationship will be spoken about on the second page. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. So we are going to go ahead and fill in our blanks. If you remember, this sign is like the Twin Towers. I told you it meant that they were parallel. So it's asking, what is DE parallel to? Well, you can use your eyes, but you can also use these triangles. The triangles, again, mean lines are parallel. So that means this line and this line are parallel to each other. So DE is parallel to line AB, which means DE is equal to half of AB. So that means if DE was 5, AB would be 10 because DE is half of AB. All right, and the same thing if you were given, I don't know, the number 20. That means DE would be the length of 10. All right, so if you know how to half and double, we're good to go. We're going to flip the page and continue. We have 3 examples. All right, so in the first, we have DE, that is X, and BC is 28. Well, DE is parallel to BC. DE is the mid-segment, which means it's half of BC. So we can take 28 divided by 2, which is 14. So that means X equals 14 because DE is half of BC. In number 2, this time, X is the longer portion. D is still the mid-segment. D is half of BC. So instead of taking half of 15, because that would help you find another mid-segment, the opposite of halving is multiplying times 2. So we're going to take 15 and multiply it times 2. 15 times 2 is 30. So X will equal 30. All right. The last one is probably the hardest for most students because they don't really realize that DE is the mid-segment, Mid-segments go from midpoint to midpoint, so D is a midpoint and E is a midpoint. With that in mind, we're trying to find the length of X, and X is on the same side as our midpoint of E. So that means, since E is the midpoint, this portion and this portion are going to be congruent. So there's no math needed. X will equal 9, because E is the midpoint. In our second section, in our second section, we're going to talk about triangles are used for strength in roof trusses. If you've never heard that word before, you see it a lot in construction. I was actually going to show you this picture. If you are familiar with Jacksonville, this is the downtown Main Street Bridge. It is completely made of trusses. If you look at it very particularly, you'll see all of these triangle, triangle, down here, triangle, even here, triangle, down here, triangle. So what I would ask is that you go ahead and next time you're on a bridge, go and look at all of the triangles that make up the bridge to help strengthen the bridge. You'll probably also notice that tables, at least the tables at school, I'm not talking about your dining room table, but the tables at school, if you notice, there's the top portion, but then there's this thing that sticks out on the bottom. I like this. It helps support the table so that when, something heavy is put on it, it's not going to fall through. All right, so enough with that. That's the word truss. So trusses are usually made up of mid-segments as well. All right, so UV, and VW are mid-segments. So all I'm going to do is highlight them in two different colors on the page. So UV is going to be parallel to RT. All right, if we notice the green and the green, it's going to ask for us to find the measure of UV. Well, we know that RT is 90, and if UV is a mid-segment in relation to RT, UV is going to be half of RT. Since RT is 90, we can do 90 divided by 2, which is 45. So that means UV will be equal to 45. Again, because it's the mid-segment, and the mid-segment is half. If we look at the other piece, which would be VW, is currently 57, it asks us to find RS. Okay, so looking at the blues, 57 is the mid-segment. 57 is half of the measure of RS. So let's use our common sense. We can't take half of 57 and it'll look longer like this. So we're going to have to actually double it. 57 times 2, which will be 114. So that means that RS is equal to 114. We're going to move along. All right, this is also in your textbook, if that's too blurry for you. We're going to find the perimeter. To find the perimeter of an object, you add all the sides. Add all the sides. Sorry, my handwriting looks like chicken scratch, but so does a lot of yours. Ooh, tough subject. All right, so we're going to find the perimeter of DEF. That's the triangle on the inside. Let's look. I see that we have these tick marks, which show that each side has been cut in half, which makes D the midpoint, and 45 a midpoint, and 38 a midpoint. I also see that we have connected the dots between the midpoints, which means all of these are mid-segments. So we are actually going to find the lengths of these sides to find the perimeter. But we're going to find the lengths of the sides using the outer triangle. So looking at AB, find the line that is parallel to AB, and that would be FE. So you would take 13 and divide it by 2, and that will be 6.5. We are going to use a decimal here just to make our life a little bit easier. All right, so then let's look at AC. AC is parallel with FD, so that means we can take 38 and divide it by 2. And that should be 19. So that means that FD is 19. And then our last side, BC, ooh, that's terrible. Not much better, but it is going to be in relation or parallel to DE. So we'll take 45 and divide it by 2, which is 22.5. So now we want to find the perimeter of DEF. So we're going to add up the side lengths. So we'll add 22.5 plus 6.5 plus 19, and it will equal 48. There was also a second way to do this now that I'm looking at this. I'm sorry, it has been a year since I taught it. There's a second way. Because all of the side lengths are half of the outer triangle, you could find the perimeter of the outer triangle as well. So we would add 13, 38, 45. So add all of them together and you get 96. So if that's the outer triangle, the inner triangle is half of that. So if you divided 96 divided by 2, you would get the same answer. You will have a problem like this on your test, so however you choose to solve it will be just fine. But either way. So perimeter, make sure you add up all of the side lengths. Number 6, we're almost finished. In the diagram, DE is a midsegment of ABC. So DE is a midsegment of the outer triangle. FG is a midsegment of triangle ADE. Find FG. So basically we have a midsegment of a midsegment. It's like Inception, but not really. So BC is parallel to DE. DE is the midsegment of that outer triangle. So that means we can take half, so 52 divided by 2, which will be 26. So that means DE is 26. We haven't answered the question yet. FG is the midsegment of ADE, so that means it is also half of 26. So you'll take 26 divided by 2, which is 13. So FG equals 13. All right, I believe this is it. It's the last example we have, and we're at 13 minutes. A walking path BD, so my walking path is right here, in a park intersects the sides of the park at their midpoints. You walk from corner A to walking path BD. So let's just kind of map where we're going. So from A, that's our starting point, to BD, over the path to the other side of the park, so we go through the path, and then up to corner E, and then back down to your starting points. How many yards do you walk? So let's break this down. Because BD cuts through at the midpoints, we see that in the first portion, B and D technically is a mid-segment. If B is a midpoint, that means AB is 90. We already know DB is 68. It's written there. We can find the length of DE because it is half of 216. Half of 216 is 108. And then the last piece we can find, because it is parallel to 68, the BD. So since BD is our mid-segment, that means the line it is parallel to will be double. So 68 times 2, I'll do it up here, 68 times 2 will be 136. So 136. I know it's hard to see. But we're adding the orange and the red. So we start at point A. I'll just do some highlighting. Start at point A and go towards B. So that's 90. So we're going to add 90. We then go over the path, which is 68. Then we go towards point E, which we decided was 108, because it is half of the full 216. And then we walk from E to A, which is 136. So we're going to add all of those up together. To be a 2, 2, 3, 4, 02. So we walk 402 yards. Just to give you a perspective on that, that is 4 football fields. It's insane. You're definitely reaching your step count at that rate. So, we have come to an end. It is 16 minutes. I tried to keep it close to 15. I will see you tomorrow. Have a great night.